Assalamualaikum warahmatullahi wabarakatuh. My name is Hariri bin Muhammad Zahid from class CS1123B. Today I will explain the question 1, which is consider an experiment of tossing two coins and rolling a dice simultaneously. Let X denote the total number of heads and Y the number that come up on the die. So first we need to know the probability of getting head or tail, which is we got here head, tail, head, tail, and tail, head, which is we got probability. So each of these will equals to 1 over 4, and for the die each side will equals to 1 over 6, the probability of getting it. So the first question is construct the joint probability distribution table of X and Y. So we need to know how many probability of getting head, which is we got 3 probability, which is 0 probability of getting head, 1 probability probability of getting 1 head, and probability of getting 2 head. So basically we got here, for the 0 probability is 1 over 4. For the 1 head we got 1 over 4 times 1 over 4, which is 1 over 16. And for the 2 head we got 1 over 4. So for the Y we will get 1 over 6 for each side. So basically for the 1, 2, 3 and so on we will get 1 over 6. So for the joint probability distribution table, you need to make it like this: X at the top, Y in the side, and then you just need to enter the value. So for example, X0, Y1, you need to enter the value of probability 1 over 4 times 1 over 6, and then you will get it. So you will get it like this. Okay, next we move to the second question, which find the marginal distribution of X and Y. So to find the marginal distribution of X and Y, you need to total up of all the joint probability distribution, which is for the X, for the Fx, you will need to total all of this. Then you will get this one. For the X1, also you need to total up all of this. Then you will get this one. Same for the F2Y, which is for the YY, you need to total up all of this. Then you will get this one. Not all of this, and then you will get this one. So same for the Y2, 3, 4, 5, 6, and same for the X0, 1, 2, 2 X0, 1, and 2. Okay, next, determine whether X and Y are independent. So how do we know that it's independent or dependent? So the way to know it is fxy equal to f1x times f2y. So if it equal, it is independent. If it's not equal, it is dependent. So in this case, we will take f01, which is this one, 1 over 24, times with, so f1x, we will take f10, which is 1 over 4, and then we will take f21, which is here 1 over 6. So 1 over 4 times 1 over 6 equal to 1 over 24, which is, it is the same it is the same as f01. Hence, X and Y are independent. For the last question, which is determine the mean and variance of W equal to 4x minus 3y plus 5. So first we need to know what is mean. Mean is expected value. So for the expected W, we will get it 4ex minus 3ey plus 5. We will get it like this. So first you need to find the expected value. To find the expected value, you need to time the probability which with its f1x. So for the ex, you need to times this one and this one. Same for the one and this one, and so on. So you need to, and then you need to total up it, and then for the ex we get this one 1. For the ey also the same, we need to total up the y value, and then we need to do f2y, which is 1 over 6. So you need to do the same, and then you need to total up all of it. Then you will get the 7 over 2. After you get the value, you just need to enter it in the formula, which is 4ex, which is 41 minus 3ey. Our ey is 7 over 2, and then plus 5 equal to negative 3 over 2 for the ew. Okay, to find the variance, we need variance of the view. We need to find the variance of x and variance of y first. Why? Because when we break down the formula, we will get this one: 4 squared variant x plus negative 3 squared variant y plus variant 5. So we need to know the variant 5 and variant x first. To find the variant x and variant y, the formula is x squared minus again expected x squared. So first we need to find the x squared, the expected x squared only. So first, how to find it? Just the same as ex, but you need to square the x. Same for the ey. So here you will get 3 over 2 and 91 over 6. Then you enter it in the variance formula, which is this one. You will get the 1 over 2 value. Same for the variant one, which is this one. And then you will get the 35 over 12. Then you enter to the variant W formula, which is 60. You will get 16, 1 over 2 plus 9, 35 over 12 plus 0. And then you will get 137 over 4. I think that's all for the question 1. Thank you.
My name is Fakhrul Radzi bin Jumahat, and I will continue with the question 2. So for the question 2, let the joint probability density function of y1 and y2 be a function of y1 y2, which is for y1 cube y2 plus y2. So for the question A, find the value of A. Before that, we need to know that the question is discrete or continuous case. So for this question, we know that the question is continuous, so we need to solve it with the continuous case. For the question A, find the value of k. So we just need to integrate first, equal to 1. So integrate y equal to 0, y2 equal to 0, k. Integrate y1 equal to 0, 1. For y1 cube, y2 over y2, plus y2, dy1 dy2 equal to 1. So the last answer, we can get the k square over 2 plus k square over 2 equal to 1. So at this answer, we can get the answer for the k. So the k is equal to 1. For the question B, we need to find the marginal density function of y1 and y2. So for first, we need to find the marginal density function of y1. So fy1, y1 equal to integrate 0k for y1 cube y2 plus y2 dy2, and we get the answer is 2y1 cube plus 1 over 2, 0 less than or equal to y1 less than or equal to 1. For the marginal density function of y2, fy2 y2 equal to integrate 0 1 for y1 cube y2 plus y2 dy1. The function is still the same, and then we get the 2y2 0 less than or equal to y2 less than or equal to 1. And then we move on to question C. For the question C, we need to determine whether y1 and y2 are independent. So if we want to know that the function is y1 and y2 are independent or not, we need to equal to function y1 y2 equal fy1 y1 times fy2 y2, which is for the marginal density function of y1 and y2. So the function is 4y1 cube y2 plus y2 equal to 2y1 cube plus 1 over 2 times 2y2, and the last answer, we can get the same answer both of them. So since function of y1 y2 equal to fy1 y1 times fy2 y2, y1 and y2 are independent. For the question D, we need to determine p 1 over 4 less than y1 less than 1 over 2, y2 equal to 1 over 2. So for this question, we also to we also need the marginal density function, which is fy1 y1 and fy2 y2. We already know before this. So we just need to know for the fy1 y2. So fy1 y2 over fy2 y2 equal to 4 y1 cube y2 plus y2 over 2y2, and then we get the 2y1 cube plus 1 over 2. After that, we can solve the question, which is p1 over 4 less than y1 less than 1 over 2, y2 equal to 1 over 2. We integrate it, 1 over 4 1 over 2, function of y1 y2 equal to 1 over 2 dy1, and the last calculate it, we can get the 9 over 32 minus 65 over 512, equal to 79 over 512. And the last question is find the mean of P equal to 5y1 minus 2y1 plus 8. To find the mean, we need to put the E at the early. So EP equal to E 5y1 minus 2y1 plus 8. So equal to 5EY1 minus 2EY1 plus 8. So to find the EY1, we need to integrate y1 with the function. So EY1 equal to 0, integrate 0, 1, y1 times 2 y1 cube plus 1 over 2 dy1. And then we get the 13 over 20 for the EY1. And then the last is we just calculate the EP. So EP equal to 5 times 13 over 20 minus 2 13 over 20 plus 8, and then we get the final answer is 199 over 20. So that's all for the question 2. Thank you.